Hi, it's David. Welcome to your lesson on understanding number. So today we're going to learn how to read and write really large numbers. But first, to really understand the number system, we've got to go back 3 million years. Now, cavemen never had a lot to count. And the few things they could count, they could record probably just by using tally marks, just scratching markings on the walls of their caves. But then as civilizations developed, there were more things to count, and so they needed to develop a greater system for recording larger numbers, because tally marks were just too complicated when the numbers got really, really big. So some ancient civilizations, like the Egyptians and the Romans, actually came up with symbols or letters to depict much larger numbers. However, doing that sometimes made writing simple numbers really, really complicated. So it wasn't until after the Romans, about 1500 years ago, when the Indians and the Arabs got their heads together and came up with a really, really clever system, an amazing system, a system so clever that it is now used by pretty much every single nation in the world. While we all still speak different languages, this unified system of mathematics has brought everybody together with one universal language. What did they do? What was the breakthrough? Two things. First of all, they found a way of recording any number, no matter how large, with just 10 digits. Why 10? Good number as any. But the really big breakthrough came when they discovered the number 0. Dun, 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 0! Why is 0 so important, I hear you cry? Well, let me explain. The first step of learning to count is to know your numbers 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But what happens when we get to 10? And here is the genius of the Hindu-Arabic number system. Instead of thinking of a new symbol for 10, we use the same symbol as we did for 1, but we put the 10 in a different place. As soon as you place the disc here, it has a value of 10 instead of a value of 1. I've put an O for 1, but often you see it depicted as a U for units, but it means the same thing. So if the coin is here, it means 1. If the coin is here, it means 10. And in order to write that as a number, you would write a 1 here, and you put a 0 here. And this is the genius of the Hindu-Arabic system. You use a 0 as a place value holder to show that there are no 1s. You can then use exactly the same 9 digits again. But this time we're using them to show 9 10s instead of 9 1s. 10, 20, 30, 40, 50, 60, 70, 80, 90. Once your column is full and you need to go to 10 10s, instead of putting it in this column, you go to the next column. So every time you need 10 discs, then the 10th one has to go to the next column along. So if you put your coin here, it means 100. This is our hundreds column. We would also need another place value holder to show that there are no 10s. 100 is one coin here with no 10s and no 1s. Then we can keep going in the same way in the hundreds column. 100, 200, 300, 400, 500, 600, 700, 800, 900. And when you get to 10 hundreds, you go to the next column like before. And this number would become 1000. We now have 1 in the thousands column, no hundreds, no tens, and no ones. And so the system continues, on and on and on. The next column would be tens of thousands, then hundreds of thousands, then millions, and so on and so on and so on into infinity. And so our number system is written by simply placing one of our digits from 1 to 9 in each of the columns to generate any number of any size. This number will be 1364. We have a 1 in the thousands column, a 3 in the hundreds column, a 6 in the tens column, and a 4 in the ones column. 1364. If, for example, we got rid of the tens, we would now have 0 tens, but we still need to show it using a place value holder. So now this number is 1304. It's crucial that you have this place value holder. Otherwise, if you just wrote the digits where there were actually discs in the columns, the number would be this, 134, which is very different indeed. So the place value holder is of extreme importance. Now, parents, if you're watching, just an interesting aside on helping your very young children to count from 1 to 20. Something very important that you have to be aware of. Counting teen numbers is very tricky for young children when they first learn how to count, and this is why. The numbers 1 to 9 are very straightforward. They each have a different symbol for a different number. And even the number 10 is straightforward enough, except really it should be called 110. If it was called 110, it would be much easier to understand. The problem with the tens column is the name that we give it. The problem comes when the numbers are greater than 10. We call this number 11, but really it should be called 110 and 1. We call this number 12, when really it should be called 110 and 2. And we call this one number 13, when it should be called 110 and 3. So you can see why children find it confusing, whereas they should only really have to learn 9 digits plus a place value holder, 10 digits in all, they actually have to learn more names for things. 11, 12, 13, 14, 15, 16, 17, 18, 19. And even the tens columns are confusing enough. We should really call that 2 tens, but we don't. We call it 20. We call this 30 when it should be 3 tens. We call this 40 when it should be 4 tens. We call this 50 when it should be 5 tens. We call these 60. It starts to get a little bit easier now because at least we're saying the word 6, but we're saying 60 instead of 6 tens. 70, 80, 90. So if you're trying to teach your children how to count early on, then you need to make sure that they understand how the numbers are represented. And that although, for example, this number is called 19, it means 110 and 9 ones. Once you've learned how to count to 100 though, it starts to get a little bit easier again. 100, 200, 300, 400, 500, 600, 700, 800, 900. And the same with the thousands. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. So just be aware when you're teaching your children to count early on the importance of understanding teen numbers and the tens. So now you've had time to look at how the number system works, we're going to play a game. I'm going to create some numbers randomly by shuffling my number cards, and when you see the number on the screen, you've got 10 seconds to say the number. We're going to start with easy numbers, and it's going to get more and more difficult as it goes on. And once you've got as far as you can go, then kind of fast forward through the ones which are too difficult for you, and then go to the next section where we're going to explain a little bit more about how it's all done. Here's the first one. Ready, steady, go. The answer is 17 because we have 110 and 7 units, or 7 ones. Okay. Question 2, 3-digit number, here we go. Is 371. We have 3 hundreds, 7 tens, and 1 unit. We're now going to try a 4-digit number. And the answer is 1,389. We've got 1 in our thousands column, 3 in our hundreds column, 8 in our tens column, and 9 in our units column. Sometimes you would either see a gap between those numbers to separate the thousands from the hundreds, or you might sometimes see a comma. Let's try a 5-digit number. So this time we have 3 in our ones column, we have 5 tens, 8 hundreds, 9 thousands, and 6 tens of thousands. So let me put a comma to separate our thousands from our hundreds. And remember, with our thousands, we can read the number and then say the thousand. So this is 69 thousands, because that's 6 tens and 9 thousands would make 69 thousands altogether. Then 853. So 69,853. Let's try a 6-digit number. And the answer is, we've got none in the units column. We've got 2 tens, we have 4 hundreds, 8 thousands, 1 tens of thousand, and 5 hundred thousands. I put a comma after the thousands, and all of the thousands can be said in one go, and then you say the thousand. So the answer is 518,420. And the 0 place value holder is really important, showing that there are no ones. Finally, a 7-digit number. Let's see how you did. So that's our ones, or otherwise known as units, our tens, hundreds, thousands, tens of thousands, hundreds of thousands, and our next column after 100,000 is a million. A million is basically 1,000 thousands. I now put a comma to separate my thousands sections from the millions and from the hundreds. And the number reads 9,721,034. Notice I didn't say any hundreds because there are no hundreds, but we still need the 0 to show that there aren't any. So now you've had a go at saying the numbers, let's practice against each other. So I want you to find mum, dad, brother, sister and play a game where you've each got a set of number cards each. If you've not got number cards, just use playing cards. And what you need to do is one person is going to create a number without the other person seeing. You could go back to back, or you could have some kind of divider in between you in order to do that. Then when one person has created the number, they're going to say the number, and the other person has to try and replicate that number. They have to find the right digits and make the same number. And then you look at each other's numbers and you see if they match. And then as you progress, try and make it more and more difficult, more and more challenging with larger numbers. 29!
My turn. 7,450,863.
Kevin the Carnivorous Caveman is going to do a comedy dance for you. Pause it at any moment, head off, play the game with somebody, and when you've done that, come back, hit play, and we'll carry on. Have fun, see you in a bit. So now you've had a go at playing the game, let's see if you can try these questions. I've given you some questions which go from easy to hard. The green ones are the easiest, the red ones are the hardest. Just pick the questions that are relevant for you. Something that's too easy, you're not going to find very interesting. If it's too difficult, you're going to get frustrated. So pick something that's challenging but fun and that you know that you're going to succeed at if you try. Kevin the Carnivorous Caveman is going to come back and do some more comedy poses for you. Pause it at any moment, have a go at the questions, and when you're done, come back and we'll look at the solutions. So let's see how you got on. Here's the solutions. So we're going to look at the solutions to the Have a Go section. I'll be doing the green solutions with the green pen, blue solutions with the blue pen, red solutions with the red pen, so you can fast forward straight to the section that you need and you don't have to watch the bits that you don't need. So starting with the green, question 1. You had to write the number 5 and it looks like this. Number 2, you had to write the number 10, which looks like this, which is made up of the digits 1 and 0 to show there is 1 10 and no ones. Number 3, the number 11 looks like this. It's made up of 1 10 and 1 1. Number 4 was the number 12 you had to write, and 12 looks like this, made up of 1 10 and 2 1s. Number 13 looks like this, made up of 1 10 and 3 1s. And finally, number 14 is a little bit more straightforward than the others because you can hear the sound of the 4 in its name. 14 is a teen number, so it's got 1 10 and 4 1s. Answers to the blue section. Number 7, you have to write the number 6. Tricky one that. Looks like that. Number 8, you have to write 60. Now this is looking for you to see that the number goes over into the tens column. Got our ones, often written as units, tens, hundreds, and thousands. So number 7 was 6. Number 8 is 60. It's just showing that there's 6 tens and no ones. Number 9, 66, looks like that. It's 6 tens and 6 ones. Number 10, 666, looks like this. There are 6 hundreds, 6 tens, and 6 ones. Number 11, 606 has no tens, and we have to show that with a place value holder. There are 6 hundreds, there are no tens, and there are 6 ones, 606. Number 12, 6060 is written like this. We have to show that there are 6 thousands, there are no hundreds, there are 6 tens, and there are no ones, 6060. Now the red section. In order to answer the red section, I'm going to do some column headings to help us out. So we have our ones, also known as our units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, and millions. And if you're ever stuck on reading and writing numbers, just write these column headings. Anyway, number 13, 2,222. So that's a 2 in the thousands column, 2 in the hundreds column, 2 in the tens column, and 2 in the ones column. 2222, 2,222. Number 14, 22,222. We just have to put an extra 2 in the tens of thousand column to show there's 2 tens of thousand. So there are 22,222. You might also, of course, have a comma here to separate your thousands. Number 15, 22,020. So we have 22,000 and then only 20, so that's a 2 in the tens column. So there are no hundreds and there are no ones. Number 16, 1,032,064. That's a 1 in the millions column with a comma afterwards to separate it from everything else. 32,000, well, that will be 3 tens of thousands and 2,000 like that. 32,000. So I must show with a place value holder that there is nothing in the hundreds of thousands column. 1,032,064. So 64 is 6 tens and 4 ones, and there is nothing in the hundreds column. 1,032,064. So that's it for today. I hope you've really learned something about reading and writing numbers. Now, the good thing about the video tutorials, of course, is you can always go back and watch them again, or you can pause them. You can look at things again if you find them too tricky, unlike in a classroom where if you miss something, you kind of can't get it back again. So by all means, go back, watch the video again if there's something you didn't understand, or try the harder questions this time, and just keep getting more and more familiar with number. All the information is there in this video of how to understand our entire number system, from reading and writing really simple numbers to really, really large ones. So have fun with that, because in our next lesson, we're going to be comparing the size of numbers. See you next time.